What'd you get for example 8? Did you come up with 3? That's the correct answer. E to the 0 is 1. Cosine of 0 is 1. So we have 1 plus 4 times 1 minus 2. 3. So if you got 3, give yourself a pat on the back. Nice job. Okay, so unfortunately, not every limit is as easy as problems like examples 7 and 8. Sometimes when we plug in the value, we have an issue going on. Let's go back to the original example, example number 1, in which we had f of x was equal to x squared minus 9 over x minus 3. We were interested in the limit as x approaches 3 of this function. All right. Now, if we plug 3 into this function, what happens in the numerator? Yeah, we get 0. What happens in the denominator? We also get 0. That's right. So we end up with 0 over 0. Okay. Now, the key thing here is we're dividing by 0. Okay. That's not a real number. Okay. And because we also have 0 in the numerator, we have something that's what's known, as you see there on your notes, as the indeterminate form. Okay. An indeterminate form, there's multiple forms of the indeterminate form. We're going to focus right now on the 0 over 0 form, and then we'll move to the infinity over infinity form of that as well. If we have 0 over 0, it's sort of like a, hey, we're not done yet type issue, because we actually know what the limit is. All right, we tried to plug it in, we got 0 over 0, but when we did example number 1, we know that the answer of the limit is exactly 6. So, how do we get from this idea of 0 over 0 using the quick and easy method of just plugging in your value to the actual answer of 6? And this is where we've got a couple of tools to use. One of the tools we have to hold off on because it's not ready for you yet, but one tool that is ready for you are your algebra skills. Okay, let's go back to x squared minus 9 over x minus 3. That numerator, can we factor it at all? What would happen if we look to factor this numerator? You probably remember this as a 4-letter acronym of DOTS, but this is the difference of 2 squares. We have a quadratic here. We have x squared and we have 9, so we have 2 squares right there, and then we are subtracting. So it's a difference of 2 squares, which means that we can factor it into a pair of binomials. Right? And when we factor, all right, we're looking for what 2 binomials will FOIL, if you will, to get x squared minus 9. Well, x squared means we have an x here and here. 9 means we have a 3 here and here. 1 gets a plus, and 1 gets a minus. Right? And then the denominator, we still have our x minus 3. Remember, we're taking the limit as x approaches 3 of this expression. Okay, and if we plug in 3, we still get the 0 over 0. But because we have those pair of x minus 3's, what can we do with them? Exactly, we can cancel them out. And if we cancel them out, they are now gone, and we are left with the limit as x approaches 3 of x plus 3. Well, guess what happens when we do our usual quick and easy method now? We plug 3 in for x, and we get the 6 that we're looking for. Okay, so if you end up with an indeterminate form, 0 over 0, okay, that means you're not done yet. The answer is not 0. The answer does not exist. In both cases, you could get an answer of 0. You could get an answer of does not exist, but we don't know that for certain yet. What we need to do is we need to simplify our expression like we did here. And after we simplify and eliminate some issues, then we're looking to plug the value as x is approaching again, see if we get an actual answer.